Right, good evening, everyone. Good evening, boys and girls. Right, today we are starting a new topic, but still on developments. Right, we are starting on transition pieces. Remember our last topic, last time we're looking at interpenetration and development. So already we've touched a bit on developments, but this time around, we want to look at a piece or part of a component such as ducts or pipes, which cannot be developed by the other two forms of developments, which are basically parallel line method as well as radial line method. So we are going to use a specific method for transition part or for transition piece, which is referred to as triangulation, okay? So I'm going to explain all that in detail with regards to how we make use of the triangulation method, what it entails, and how do we go about it. So I want us to look at that which we are going to focus on today. Like I said, we are going to look at triangulation, right, which is mainly applicable to the concept of transition pieces. Right, I'm going to illustrate those transition pieces and how we end up having those transition pieces. Right, what we are going to do, we are going to copy the given views, right? In most cases, you find that these views are to do with the ducts. Then we're also going to do surface development of the transition piece only, right? And given a specific age, right? But in this particular task, we are going to look at AB as the scene. Right, we are also going to show all necessary construction lines and fault lines. Just like I've always been saying, right, you need to be practical about this subject in order to understand it, right? This does not require more emphasis than what we are doing right now. So please make sure, as much as you are watching this video, you take a drawing board and a paper and start doing the work so that you understand what we are doing as well. Right, tomorrow we are going to meet for our interactive session. So I want you to make sure that you have got all questions that you may want to ask so that when we meet tomorrow, you have got all those questions, you post those questions to me and I should be able to respond accordingly. So boys and girls, enjoy the lesson and good luck. Right. Like I said, today we are going to look at transition pieces. Right, we are going to start with a diagram like this. Right, it's coming from one of the workbooks. Right, and what is it that you are supposed to do? Right, the information that is given reads as follows. The front view and top view of a portion of a duct showing a square-to-square transition piece with two connecting pieces. Right, so you have got this is our top view, this is our front view. Remember, it's in first angle orthographic projection. So what you see from the top is drawn at the bottom. The instructions: draw to scale 1:1 and in first angle orthographic projection, the front view and the top view of the given portion of the duct. So you are supposed to simply copy these two views. All right, as you copy that, please make sure you copy according to the specifications which are given, because the idea of copying, again, you get marks for that. Develop the surface of the transition piece only. Right, we are told that there is a square-to-square transition piece. Right, what it basically means is that here is a square. From here, we have got a square prism, and from here going downwards, we have got another square prism. But as you can see, right, the shape is not the regular one, and the size is also changing from this big square to a much smaller square. Right, so what it means, therefore, is that this part of the dot, right, from here to there is what we refer to as the transition piece. Right, it is a part which is changing from a bigger square prism to a much smaller square prism. And as such, we refer to that as a transition piece. So it's changing from one size to the other. That's all what it is with regards to transition pieces. Right, you'd find that it can be a square base, right, and a cylindrical upper part, okay? Right, and as such, you may not be able to develop with either parallel line method or radial line method. And you would need a special type of method which we refer to as triangulation. Right, it's not a complicated concept. You would find that when we are referring to triangulation, we basically create a series of triangles on each surface that you are going to develop, okay? Right, remember when we develop, we're basically opening the shape out such that it lays or lies as a pattern or as a template. Then we cut the material according to that template. So we are going to create a series of triangles, find the true sizes of those triangles, patch them together. Then you come up with a pattern that we refer to as a development, right? Remember what I said from my introductory part? You need to be practical in order to understand this subject. So by merely explaining like this, I know quite a number of you would not make sense of what I'm talking about. So let's go on and draw these views. Then from there, we'll be able to explain the other details. Right, I'm just going to measure from here to there, 35, just to offset or move away from the edge. Draw a faint line like that. Bring a 45 degrees set square like this. There you go. Right, so this point, I want it to be that point. Right, I've got this big square, right? It's square 50 millimeters. So I'm going to measure from here to there, 50 millimeters, right? Then draw a faint line like that, okay? Right, so from here to there, it's 50, but because it is a square, right, I can extend this line like that, okay? Then bring this one, there you go, okay? Right, so I do have now the first square. I can outline this. There you go. Right, so that is the square. Right, when you see as a measurement where it says 50 Q like that, it basically means this side is 50 and it's a square, okay? Right, then the next thing, if you check, there's also a smaller square, okay, which would be reflected here at the top. All right, now what I would do, I would find the midpoint, and faintly like that. then also do this like that. Right, the square is 12.5 in terms of half the side, but the actual size is 25. So what I would want to do, right, I would measure from here to there, 25, which would basically be here, okay? Right, then I would take this one up. Right, now, if this side is 25, right, I need from here to there is 25. I need another side, which is also 25 from here to there. So what I can do is I can simply miter here, right? Let me miter there. Like that. Remember, I don't want to measure often. Do this, okay? Right. So if I draw a line via this point, automatically I will be able to get one side 12.5, another side 12.5 without necessarily measuring, okay? Right, so created the midpoint, then through that, that's a diagonal. So if I do this and also do this, I've got another square, right? Therefore, you can outline this. There you go. Now I've got this top part and I've got the bottom part. As you can see, this bottom and top part are connected. I'm going to do this and leave this. Right, okay. Now I've got my top view, right? And the other thing, right? Here you can create even a ground line, it's fine. You can label this one X and Y, okay? Right, leave some space, right, like that. You'd measure 15, 40, and 15. 15. 14. Right, I'm drawing the complete thing, but in an exam setup, you'd find that, right, you may just draw this part only, the one which is the transition piece, but I want to show you how this is started and how we end up having something like this. Right, so from here to there, it's from here to there, which is the same as that. That is another prism, okay? Which is the smallest prism, side 25. Then from here to there, which is the same as that one, that is another prism as well, which is side 50, okay? So I'm going to connect here faintly, right, like this. There you go. We have created the given shape. Then the next thing is to outline. And I'm going to outline from here to there, from here to there, and also here. Right, when you are outlining, have a system, right? If you are dealing with horizontal lines, deal with those horizontal lines first. And when you are dealing with vertical lines, likewise, you concentrate on those vertical lines. There you go, right? I'm just left with this one. Like that. So now this is a normal prism which can be developed. Like I said, there are three main. But let me just explain something here with regards to developments. Okay, But if we are going to talk about developments, we have got three main methods that we use, okay? The first one, like I said, is known as parallel line methods, right? The second one is called radial line methods. Last but not least, it's triangulation, which is our focus today, okay? Right, and what do these methods relate to? You'd find that with parallel line method, right, it is mainly focused on prisms and cylinders, all right? And you'd find that there's something which is common with regards to these ones. They do have a uniform cross-section, okay? Right, whether you cut at the top, in the middle, as long as the cutting plane is positioned the same, the section would basically be the same, okay? Right, what the section or the shape of the section that you produce would basically be the same. Right, now when we are looking at this one, right, it is mainly to do with, right, pyramids and cones, right? And there's a specific characteristic about these. These are defined by a base plus an apex, okay? Right, so this radial line method is applicable to pyramids and cones, right? And basically you would see that the characteristic of these geometric shapes is that they've got a base and an apex, whereas if you look at a prism, they've got two identical faces, either at the top or at the bottom. The same applies with a special type of a prism, which is a cylinder. Right, a cone is a special type of a pyramid, okay? All right, then when we look at triangulation, right, this mainly focuses on transition pieces, right? Transition pieces whereby you could be moving from a prism to a cylinder, right? And the space in between, it's in transition, okay? Right, it's changing from one form to the other. Then we refer to that one as a transition piece. Like you'd find that in most pipes that you see at big factories, you have got transition pieces, okay? All right? For the extraction of fumes from factories and so forth, they do mainly make use of this concept of triangulation in order to create those pipes, right? Which are basically in form of transition. So we are going to focus now on this one because this one, we looked at that when we were looking at our interpenetration and developments, which were basically prisms, cylinders, pyramids, as well as cones. Right, okay. We are also given, right, in terms of our question, that this part from here to there, that's our seam. Right, our seam is basically the part that we open through or we patch through, okay, or along. Right, so I'm going to change from A to B to 1 at the top and A at the bottom, such that I have got this point number 2, this point number 3, this point number 4, okay? So I've got 1, 2, 3, and 4. This one, I will say it's B, C, and D, like that. Right, if I were to relate, right, to the top part, remember, I'm not worried about this, I'm not worried about that. I'm only worried about that part which is in transition, which we refer to as a transition piece. So this one would be A, B, right, and this one would be 1 and 2, like that. This will be 4 and 3, 4 first, and then 3 on the other side. The same applies, this will be D and C, okay? Right, of course, you won't lose marks if you say C and D, but technically, looking at the concept of visualizing, right? You need to define that which you see first before you talk about the detail which is at the back. Now, this is just the drawing that we are given. Now, when we are talking now about triangulation, okay, right? If I want to develop this surface to its true size, right, I need to create triangles, okay, maybe a series of triangles on the different faces, right? So from here to A, right, that's a line, right? I can connect from A to number 2. I have created a triangle. So I'm going to do that. Right, like this. There you go. So I've got triangle 1A, 2. I've got triangle 2A, B. Right, that's not complete in just like that. Once you have done this, you then require to come up with the true sizes of each and every line that we have. Right, you see I connected from A to 2. Now I'm going to connect from B 2 to 3. Right, let me slide this. There you go. Right, what it means is that I've got triangle 2B3, I've got triangle 3B and C. Right, now if you are looking from the left-hand side like this, right, there should be a line which is connecting from C to 4. Remember, point C, it is at the bottom, and point 4 is at the top. So that line is already there, but we cannot see it clearly like we were able to see these other lines, right? Then we now have got, so we have got triangle 3C and 4, and we have got triangle 4C and what? And D, okay? Right, then we also connect this one to here, like that. Right, so we have got triangle 4, 1D, and we have got triangle 1D and A. Right, what I was talking about with regards to the back side, when you are looking from the left-hand side, I just want you to get a picture so that you would appreciate what we are talking about. Now, if you are looking at this, let's suppose you created a mitre line here, right? You have got this part, like that. There you go. Right. We said this is point 1, this is point 2, this is point 3, this is point 4, that's A, B, C, and D. Then we take this one up, take this one up. I'm just going to define the transition part only. You have got that, you have got this, okay? Right, so if I project this one, we say this is A, this is 1 and 2, right? This is 4 and 3, this is D and C, like that. So if I were to outline this, right. What is critical in drawing is to make your picture before you start drawing. Do not think as you draw, understand what you are drawing before you start drawing. So if I were to project this like that, take this one up, right? You would find that there is my point 1, right? And there is my point, right? But before point 1, there's point 4, then 1. So there's 4, 1, there's 3 and 2, right? Looking from the left. Now I will do this to the baseline. I've got point C, which is in line with B, right? I have got that, which is in line with D and A, right? Then these are connected like that. So I can outline like this. I need you to have this picture so that you would understand why we are saying there's another line there, right? Remember, we were connecting, we have got this point C, which is here, right? And point C should be connected to point 4. There you go. So now we have got triangle 3, C, and A, and D rather. Right. So these are the triangles when you are looking from the left-hand side. So we'll say this is our left view. Right. So you need to create this picture in your head, right, in order to understand how you would end up having a line like that. So we would need a true length of this one as well as we proceed with regards to our work. Right. I'm hoping that you understood that part. Right. So there is a line from C to 4. Now, once you have done this, the next thing that you're required to do, right, the next thing that you're required to do, right, is to establish the true length. Just a moment. Right, sorry about that. But I was just checking for color in terms of different color that we can use. Right, so we have got these lines. Unfortunately, right, I don't have that specific color. So what I'm going to do, I'm going to define this one as a different line altogether. Right, I'm going to show it by way of a dotted line. Right, from here to there, right, so that we are able to appreciate that. So this line that I've created, right, you can see it's different to the outline, right, and I'm also going to do this. Like that, right, so I've got now, right, the triangle that has been formed is 2B and 3, right, as well as 3B and C, right. I hope you are able to see from there. Right, then you have got this one. This is another triangle, okay? Right, remember what I explained? Right, if we are looking at this one as well, we have got a specific line which is being connected from C to point number 4, right, as you are looking from the left-hand side. So there is a line which is different to the outline that we have, right? So we would also require to have a true length of that line. Right. The next thing that you would want to do, right, is to establish the true lengths, okay? Right, basically there are two ways that we can use in order to establish the true length. I'm going to demonstrate the two ways of establishing the true length, okay? Right, if I'm standing here at point, you have got line 1 to A, there's also 1 to A. We know that in descriptive geometry, grade 10, right, the moment you have got two inclined lines like that, you don't have a true length. right? You can only have a true length if one of the lines is parallel to the ground line or both are parallel to the ground line. Remember, we did define the ground line like that. So if this line was parallel to this one and this one was inclined, then automatically the one which is inclined would give us a true length. But in this case, we do have an inclined line and an inclined line like that. So what we need to do, right? I'm going to use rabating methods, right, in order to establish the true length. The true 1A, which basically would also be the same as 2B, okay? So I'm going to indicate here with a small little line like that to show that this line and that line, they are equal, okay? Right, so I stand at point 1, open to point A, like this, then describe an arc. Describe an arc like that. Right, so I've moved point 1 from here to the line which is parallel to the ground line. So this is technically 1A. So the view that I'm going to see relative to this now would be a true length. So I'm going to take this one up like that. Get a point here, then relate this one to the top. Right, faintly first, I'm going to show this one like a center line line, just to make sure that we are able to see this is a different line to that one, okay? Right, so this line, I'm going to mark just with a line like that, which is a representative of 1 to A as well as 2 to B, okay? Right, the next line that I want to have is my true length, right, is 2B, right? This has no relation to any other line, right? So I'm going to stand at B, at 2, project this one like that. Right. Stand at 2, open to A, like this. Then once you have done that, you can now swing like this. Let me show you. Swing like that, okay? Right? So this has now been rabated, right? We sometimes call this one the cone generator method in our grade 10 work, right? Then you take this one up. There you go. Right, 2 is still here, so I can connect this one like that. But remember, I said for the true length, I'm going to show them like center lines like. Right, okay. So there is my point. Right, A. 2 is still there, so I've got 2 to A. Right? The next line that I want to rabat, right, is 3 to B. Remember, 2B is the same as 1A. So that one is already covered. So 3 to B, right? I would stand at point number 3, open to point B, then describe an arc like that. Right, what is moved is point B. 3 is still there, right? So I'm going to move point B as well from here to the new position. Right, take this one up like that. Right, remember 3 is here, then the point B has moved from here to that point. So we will do this. Right, faintly initially. And so that we are able to see the difference in terms of lines. Right, okay. So this, you can even write here, this is your 3B, okay? Right, so that when you use them, you are able to use the correct line. Right, then this one is 3C. If you check this line and this line, they are basically equal. right? So 3C, right? I'm going to rabat again, using point 3 as my standing point, open to point 3, to point C rather. A swing like this. There you go. Then take this one up. Then connect point 3 to the new position of point C to give you a true length. Right, I can say this is 3C, which also is the same as 4D, like that. Right, now I also said that I can know it by this graphic. Right, the next one that I need is from 4 to C, or 3 to C to 4, like that. Right, I still want to use that. Let's hope it will fit. Here we go. Right, okay. But I'm going out slightly, but I think I should be able to define my line. And you are also able to see. Let me take this one up. There you go, okay. Right, it's slightly outside, but I don't want to congest this side. So I'm going to extend this like that, okay. Right, so point C has been shifted from here. Now 4C is lying parallel to the ground line. Right, so now if I connect this point to that point, I have got the true length. Right, so I will do this. Interface to define like that, okay. Right, I can even label this one, that's 4 to C, or C to 4, which is one and the same thing. Right, remember I've got 4D, which is already here. Right, last but not least, I need this measurement, right, which is D to 1, okay, or 1 to D. Right, if I'm to maintain, right, I swing like this, right. Take this one up, right. There is point 1, right, which should be connected to point D here, but D has shifted to this new position. So I have got that. Then there's a center line like, there you go, okay. Right, so this is 1 to D, which is 1D. Right, there are certain things that are not going to change here. Right, if you check D to A, they are both parallel to the ground line, so they are true lengths, okay? Right, if you check 1 to 2, it's seen as a point here, so automatically this is a true length. So those concepts that we did in grade 10 with regards to descriptive geometry, they now come handy in terms of our work. All right, now I said there are 2 methods that we can use. So for the sake of time, in our next task, I'm going to use a different method in order to illustrate the establishment of the true length. Right, we are told that this should be our seam line, okay? Right, and if we take that, you'll find that when we stood there, right? Remember, we stood at this point and we're able to describe, you'll find that this now is the true length of 1 to 8. Now, what I would urge you to do, right? You can just draw a faint line like that, right? Then you mark a point, let me start here, and say this is point 1. That's point 1, right? But from point 1, you need point A, which should be taken from the true length. So you can either use your canvas, right? Stand there. You take the true distance now. which is this one, right? You stand at point 1 like this, then you mark. There you go. I have got now point A. Right, that line from here to there, right, you can outline, that's the true length. So I can outline this from here to there. Now, the next thing that I want is to find point number 2. Right, remember this is a true length, so I have got two standing position, point 1 and point A. For me to get to point 2, I need to say 1 to 2 and A to 2, okay? Right, so you take your compass like this, right? And you stand at point 1, describe an arc. There you go, faint arc like that. Then you stand at point A with the true length A2, right, which is here. So you take this one like that. That is the true length A2. Then you come here and you describe an arc. To cut that first arc, you have got a point, that's point number 2. Right, so you can connect 1 to 2, like that. Then connect also this one. Right, this line here, right, it can be outlined because it's not going to change, but the other line is just for the definition of the concept of triangulation. Right, once we have done that, you now need point number B. Right, how do we get point B? You need to have two standing positions. You have got 2 to B and A to B. Remember what I said, as you look at a line and see a line as a point in one view, automatically that line is a true length. So you are going to take AB as it is, right, which is 50 millimeters. You take that, go here, and describe an arc like that, all right? Remember what we said? This distance from here to there is the same as that one. You can go back to the true length diagram, okay? But you can also take the same distance from here to there, right? Which is 1A, right? So you can take this one like that, stand at point 2 and describe an arc. Right, there you go. You have got now point B. But you connect point A to B and 2 to B like that. That is your first panel, right? So the true size of this panel is now defined like this. So you can outline this from here to there, and show this line from here to there as a fold line because it's going to be folded. So, like that. There you go. Right, the next point that I require is point number 3. Right, point number 3, remember, 2 to 3 and 2 to 3. In both views, they are seen parallel to the ground line. So what it means is that this is a true length, right? Like I said, if you have got that detail, right, you can forget about going up there, right? But this is only applicable if you really know that what you did first is correct, because it would have a cumulative effect in terms of an error, okay? Right, so this, somewhere on this arc would lie point number 3, okay? Now I need the true length, right? The true length 3 to B, which is B is here and point 3 is there. So you take this true length like that, take that, there you go. All right, then you stand at point B, describe an arc like that. You connect this one to there. Faintly, remember this is point number 3. And this point number 3 is connected to B, like that, right? You can now outline this, but this one is not outlined. It will remain like just like that. Right, once you have done that, you now need point C. You have got point 3, you have got point B, so you can do B to C and 3 to C, okay? Right, so you look for the true length 3C, right, which is here. Then the true length B to C is there. Right, let's start with BC, right, which we said is the same as this one. So you can take this, come here, describe an arc like that. Right, take the true length now, 3, 2, C, like this. Take this, stand at point number 3, then describe an arc like that. Right, so what we have established now is point C. Right, and this is connected to, right, to number 3. C is connected to 3. Then you connect this one like that. You can also outline this, okay? Then you can show this one as a fault line. Here. There you go. Right. Then from there, we require now point number 4 again, because 1 to 2 and 2 to 3, they are basically equal. So you take this distance from here to there, you stand here. At point number 3, you describe an arc like that. You now require 3 to 4, okay, which is the true length from here to there. C to 4, which is the true length which we defined like that. So I'm going to take this true length. Like this. Right, you stand at point C, right, and you describe an arc like that. There you go, you get a point. That point is point number 4. You connect this point to number 3, like this, okay? And this would also be connected to C, like that. Okay. Now, this can be outlined. It's a cut line. So I'm going to outline this. There you go. Right, the next one that we require is point D. So I need 4D. Right, remember 4D, I put it earlier as 3C, okay? All right, so I'm going to take this one, 3C, right? Which is the same as this. So in order not to waste the time, you take this one, right? You come here, you describe an arc like that. Right, then you take the true distance of C to D, which is this one. You stand here, you cut this one like that. There is point D, right? You connect this one to there. You have got now this, then you take this one back. Right, you can outline this. There you go. Then this has to be shown as a fault line, like that, okay? Right. Then from there, we require now to come back to our starting position. Like I said, you take from these ones, the ones that we've established already, like this. You describe an arc. Please make sure the instruments are in position. Right, so from here, you describe an arc. On this arc would lie point number 1. Then we need D to 1. Right, D to 1 is this one, which is the true length. So I'm going to take this. There you go. Stand at point D. Describe an arc like that. The two arcs would meet. There it's point number 1. connect this one, and also connect this one to there. Right. This, again, you can outline. This one is just for the description of the triangles. Right. Now, we need D to A and 1 to A. Point 1 is there, D is there, so we need this stretch, which is the same as that one. So it's a true length. So we are not going to worry ourselves. So we'll simply take from here, because this is the established size. Then we describe an arc like that. Right. Then we require 1 to A, which is this one. We are going back to our starting position. So which is this, like that. Then you stand at point number 1, you describe an arc like that. Here is your point A. So if you open through point along line 1A, you should also end along line 1A. So I'm going to connect here. There you go, okay? This can be outlined. Outline this. Outline that. Right, boys and girls, this is our development or our pattern, which can also be referred to as, right, like I said, it is our template, our development, our pattern. So you need to write now and label, right, like this: development, transition, transition piece. Right, it's a very interesting concept, right? But you need to be extra careful in terms of accuracy and also in terms of noting your true length, right? When you generate your true length like this, right, and they are seen to be coming from the views, there's no need for you to write true length diagram, right? When I introduce another method of establishing the true length, I will show you how you would treat that one as well. So I hope you enjoyed the lesson and you managed to iron out certain concepts that you may not have been familiar with or you may not have understood, but in your earlier lessons. So this should help you now. Boys and girls, for today, we are going to end here, right? We meet again tomorrow as we look at another task regarding to transition.